Okay, thank you very much.
So I have started recording, sir.
Okay, Kumar Pedi. Thank you very much. Really appreciated. So that's good. Okay. So I informed the management also that it's not required. You have on the okay, informed right. So welcome back. Happy to see you all. Okay, not all. There are, it seems when I look at the individual assignment, there are 70 students who have submitted, but I can see only 7 people out of that. That means 7%. I know today is a weekday evening, so that's why we are having this online, and because there are much to be discussed. Okay, so what we'll do is we will commence the lecture, because today I'm going to discuss a very important analysis, right? So we have discussed finally the factor analysis and the reliability analysis. And so those are the things that we discussed last time. And today what I'm going to discuss is about a very important package called Smart PLS, right? So first of all, we'll try to see how to get Smart PLS. The trial version is there for 30 days. That's the trial version. And then I'll tell what happens to the trial after that 30 days. It becomes quite a limited version where you can do the analysis, but the maximum number of observations that you could have at any given time is 100 observations. So after 30 days, it becomes the student version. They call it the student version, right? So we'll try to understand what are those, the trial version, student version, what's Smart PLS, and today I'm going to elaborate that to you and hope you can apply that for your group assignment as well, right? Okay, the group assignment is due this Saturday. Okay. And sometimes, of course, there will be an additional lecture on Sunday as well. So maybe we'll take presentations both on Saturdays and Sundays if time is not sufficient, right? If the time is not sufficient, then we might need to think of that as well. But again, I hope to complete all on Saturday. But if time is not enough, we need to see, because there are 15 groups, right? There are 15 groups, so we have to see how we could manage 15 groups, right? So it's quite a task. So, but again, we have to manage it. And yes, that's about your assignments and the group assignment, right? Okay, so right, we'll then try to commence today's proceedings, right? So let me share the screen with you. Hope you can see my screen. Can someone please kindly confirm?
Yes, sir.
Okay, thank you, Buddha. Thank you very much. So if you go to week 13, there's something called Smart PLS. Right, week 13 is Smart PLS, week 13. So that's where you can read and apply Smart PLS, and it's the package that we are going to use. Today we are going to discuss about that and how to do analysis using Smart PLS. And I'm going to teach you in and out of Smart PLS. That's an important package. Right. Okay. So first of all, let's see how to get this package. So if someone is doing this with me, you can do it with me, right? I will tell you exactly how you could get Smart PLS and install it in your system. But remember, after 30 days, it becomes a trial version. And if you want to use it again, on the computer that you are installing, you have to buy a license. 1 month license is also there, but you don't need for the trial 30 days. But afterwards, you'd have to have that license purchased. It's a little bit of expensive, but again, I don't think any one of you need to purchase that. You can use the trial version. Okay. So how to get Smart PL? This is what I'm going to show you now. So you can go to Google and you can go to Smart. Just type Smart PLS. It's one term, Smart PLS. And you can see there are search results. Here, the first search result is Smart PLS. And you can go to downloads. Then Smart PLS 4.1.1.4 is there. That's good. And based on your system, you can download the Windows version, or you can download the Mac OS 10 version. Or even if you have Linux, you can install the Linux version as well. In Ubuntu, you can install that, and it's the free trial version. And I'll tell you how to install that and how to use it. So please download it. So click on download, it will download. And once the installation file downloads, double click on that. And then it will start installing. Since I have already installed it, I'm not going to install it again. I'll play a video that shows how to install it. So I have already installed it. Let's see, where's my Smart PLS? So what I'll do is I have to a little bit quit and come back. So please stay. So you will see how to install it. So therefore, please download it while I'll go back. I'll go and I'll come back. So, right, please wait. Students, can you hear me?
Yes, sir.
Okay, right. Okay, so, students, let's see how we can install Smart PLS, but my Smart PLS also has an issue. So it gets shut down. So we'll see how to install Smart PLS, right? Okay, once and for all. Okay, so let me share the screen. Okay, so we will go to Windows installer. You can download it. So download it, and then I will play a video on how to install it. Right. So because I have already installed that and I don't want to reinstall it. So let me play a video on how to install it. I'll explain what this guy is telling. It's the same thing that I was explaining to you. Okay. So let's listen to him. So as I told you, go to Google. So when you are trying to run it for the first time, it will give three options as this indicates. It's a student's license. It's a free license, but only 100 observations could be there in your dataset. Then there's a professional license and then free 30-day trial license. So more or less this will be the same in your case, right? Then use the, so you have to use the free 30-day trial license. Free 30-day trial license, that's what you have to use. So let's use that. So then for the getting the trial, you have to give you a valid email address, because to a valid email address, you will get your trial code, the activation code. So give your first name, last name, and then it will send it to your email, the email address that you give, right? Okay, let's proceed. So after 30 days, you can convert it to the student version. So you can then create the workspace, and that's basically when I go back. So here it says workspace, create workspace. So you can select a workspace or create one. So first time you can create a workspace, right? And okay, students. So why I'll give you 2 minutes. I'm going to quit myself and I'm going to open Smart PLS, right? So why not take 2 to 3 minutes and download it and install it? Okay, till if I'm going to try, then my Smart PLS to be opened, right? I will try. So therefore, I'm going to quit a little bit. Why not you try to install Smart PLS? So we have 28 students. So why not some of you try to install Smart PLS and try to do that? So I'm going to leave a bit and I'm going to come back after about 2 3 minutes. So please see if you can install Smart PLS. Students, can you hear me?
Yes, sir.
Okay, Buddha, thank you. So, yeah, so you will see, Buddha, thank you very much again for the confirmation. So we are very fortunate it's working. I was a bit worried whether this smart PLS of mine would work. It's working. So here you see, so first of all, you can go to new workspace, right? It might be that your buttons might be a bit different, but somewhere it should say new workspace. So first of all, you can go to new workspace and then you can set a folder. So you can go to C drive, wherever, and you can create a folder, new folder. Maybe you can say smart PLS, right? Just can say create a new folder. So you can select an existing folder and you can say select. So, or you can go to desktop and create a new folder as well if you really want. Desktop, and you can create a new folder and you can create that. So then it will set the work folder. Work folder is where all your files will be saved. Your diagrams that you draw under Smart PLS, because these visual analytics, you'll be able to draw a diagram and you can run a regression, the next generation of regression easily, right? So that's how you install Smart PLS and use Smart PLS. And after that, you can go to new project and create a new project, which I'm going to show you shortly. So before we do that, we'll go back. We are extremely fortunate. Smart PLS is working in my case, right? And you can go to the LMS and please download the first PowerPoint file, Smart PLS Workshop 4, right? So that's the file that I'm going to use. Okay. So please download and open it. So I'm going to open it already. I downloaded it. Okay. So it's structural equation modeling using Smart PLS. Structural equation modeling is the advanced, right, regression analysis to check complex models, right? When there are complex models, complex regression analysis, you can perform Smart PLS. Now let me show you some complex models. These are not so complex, but let me show you some complex models. So for an example, if your regression analysis is like this, you have an independent variable and you are a dependent variable, and there is another variable that's impacting this relationship. We call this a moderator. This is a moderator. Now, for an example, salary is impacting satisfaction. Gender can moderate that relationship. Gender can strengthen the relationship or weaken the relationship. Age is also an example for a moderator, right? Then if you look at the mediator, you can see salary is impacting satisfaction and satisfaction is impacting employee performance. So you can see this comes into the middle. So this is called a mediator. Now earlier, we did not have this kind of relationship. We had only independent variables and a dependent variable. But now, these kind of complex relationships could exist. To test these things, what we can do is we can easily use structural equation modeling, right? So structural equation modeling, because normal regression data cannot handle these kind of complex models. So we are trying to use these kind of, if you want to check very complex models, you can use structural equation modeling without any issue. Okay. So that's structural equation modeling. So there are two kinds of structural equation modeling. So let's see what are those. So as you can see here, we have, let me put into the slide presentation mode. Okay, so you can see that there are two structural equation modeling approaches. One is called CBSIM, which means covariance based SIM. Just understand this. These are two methods. Covariance based SIM, structural equation modeling. And to do this covariance based SIM, you can use these packages called AMOS, EQS, Literal. Here, one student's microphone is unmuted. Do you want to tell something? Kumarapel? Mistake. No problem. Okay, so again, if I come back to this, you can see that there are two approaches, CBSIM, and the other one is the most popular one. The other one is called PLSIM, partial least squares structural equation modeling. SIM stands for structural equation modeling. So there you can use packages as Adenco, PLS graph, Visual PLS, Smart PLS, and WAP PLS. Likewise, there are different packages. But out of this, the most advanced package is Smart PLS, though it's a paid version, a paid package. And unfortunately, it doesn't give the full package free. Now, when it comes to Stata, they gave us the full package free, at least for 6 months, and we can extend the license. But Smart PLS, it's not free. It's not free. It's a paid package, and it's expensive, as I told you. Right? It's expensive, and it's quite expensive, right? So, but again, that's the best package I have seen in the market, and that's what I'm teaching you, the best one, right? So you can use 30-day, trial version without any issue. But after 30 days, it becomes trial version, and whatever said and done, even if you reinstall that, it recognizes your hard disk ID, and it won't allow you to reinstall it again on that computer ever unless you purchase a license, or you can have the trial version. So therefore, we are going to learn partial least square sim using Smart PLS. Smart PLS is the name of the package, right? And we are going to use PLS sim. Okay, is that clear? So just to summarize what we did, structural equation modeling is where you could test complex relationships, right? Very complex relationships, several mediators, moderators. So things like that could be checked using structural equation modeling, right? And then I told you that there are two approaches, CBSIM and PLSSIM. So PLSSIM, you can see here, is the most popular one these days, and also very powerful compared to CBSIM. And there are packages like Adanco, PLS Graph, Visual PLS, Smart PLS, and WAP PLS are some packages that could run PLSSIM. But out of these, I told you the most popular one is Smart PLS, and the most powerful one is also Smart PLS. It's indeed, as the name says, it's smart. And you can run visual analytics. Now for today's session, let's use a small case study. The case study is this. Refer to the document case study, RA Music Premium case study. And we'll download the Excel file as well. Then we have to import this information into the Smart PLS software, which I'll teach you how to do that. Then you can draw the conceptual diagram. The conceptual diagram is where you can show the independent, dependent variables. So here I'm going to take 3 independent variables and a dependent variable. So here this is a music premium case study where we are going to see that how these 3 independent variables impact the dependent variable purchase intention. This is a music premium map. We'll see the case study shortly, and you'll understand that there are 3 independent variables and a dependent variable. And then I'll tell you how to run the model in Smart PLS. Right? So let's go to the case study now and try to understand. First, the basic case one, then I'll put a moderator and show you as well later on. So not required, don't save. By the way, this was completely created by AI. So this was created completely by AI, ChatGPT AI. So I think you know how to use that, right? Later on, I'll teach you that. Maybe on Saturday, I'll teach you. So I'm testing new software and new things. So if you want to create that one, you can go to ChatGPT and use agentic AI. It has that agentic AI. So you can upload any PDF file or whatever. And so here what to do, it is you have to go slash an agent. So then you can go to the agent mode in not smart PLS in here. And then you can upload a file. I'm just showing something else. Huh? Let's say I'm going to upload a PDF file. Let's upload any file. Now this was the example I took. So I'm taking the ISSA 5000 standard on sustainability assurance. And I'm going to upload it and I'm going to say, okay, prepare. So it's the standard, right? Just showing something not related to smart PLS, but very much related to your productivity. Prepare the PowerPoint with 25 slides. Or let's say 30 slides. 30 slides. It will take a long time, but again, 30 slides summarizing that above standard. Right? So you can say summarizing the above standard and just hit enter. That's all. It will take some time, right? Because it prepares each and every slide, right? So if you have the paid version indeed, so it's starting its desktop and then it will create that. So let it do its job, right? And I'll show you later. So let's go back here and then let's go to your LMS and now download this case study audio. This is a Word file and then the related data set in Excel. Please download these 2 files, right? That's enough. And then I have already downloaded, so let me open it. And you can see, right, it's still thinking because it's a lengthy task and it prepares very professional slides. I'll show you. Okay, right. Then what you'll do is you will go back to the downloaded location and open the case study, the RA Music Premium case study. So I'm going to open it. So let's read the case study, then you'll understand that conceptual diagram. What's that conceptual diagram? You'll understand. Then this is the thing. With an entrepreneurial spirit, now let's read the case study. With an entrepreneurial spirit, a group of students expects to introduce a music streaming app and has launched a trial version with all premium features for a limited time. They intend to know the purchase intention and other dimensions of the premium music app and distributed a self-administered questionnaire on the trial users. So they want now, what they have done is students like you got together and they launched a trial version of a premium music app. Like for an example, what are the music apps that you know? What are the music apps that you know? One popular one is there. Sorry? Yes?
Spotify.
Spotify. Very good. Excellent. That was the thing that was in my mind as well, Spotify. Now, what they have done here is they are launching something similar, right? A trial version. Right? Again, let's say for 3 months trial version, and after that you have to pay. So what they're trying to ask is they are given the trial version and they are trying to ask the users, trial users, whether they would purchase this, right? So for that, they have given a questionnaire to the trial users. And the information is given in the Excel file. The Excel file, you can download that. So not a data SPSS file, you are given the Excel file. So because why? They are trying to see the purchase intention. And they are given the questionnaire. The question is here. So this is the questionnaire given to the trial users. So it asks the gender of the trial user, age, marital status, highest academic qualification, monthly gross individual income, how do you usually listen to music, and then in part B of the question, it asks about Likert questions. 1 to 5 Likert questions, strongly disagree, strongly agree. So the first question is opinion leadership. That's an independent variable because we know our purchase intention might be influenced by opinion leaders. Opinion leaders are people that we trust and we think they are influencers. We call them influencers as well. Social media influencers are also there. Likewise, these are opinion leaders that now, for example, those days, not now. Now no one would listen to them or no one would believe what they say. Like for an example, Mahela Jayawardena and Kumar Sangarkar. I don't know whether anyone would be listening to them now, but I have no idea. I'm not influenced by these opinion leaders. I'm influenced by certain things only, like the features of an item. I'm not influenced by brands, but I'm influenced by the features as well as long durability of items. Right. But again, these opinion leaders and whether they have an influence of the purchase intention. Then you can see there are at least 4 questions asked on this variable, opinion leadership. 4 questions. Then you see the functional value. Some people are influenced by functions. So there are again 4 statements on functional value. Then emotional value, you can see again 4 statements are there. In fact, 3 statements are there for emotional value. Then social value, you can see there are 4 statements. Then finally, purchase intention, you have 4 statements. So I told you already, right, why you would have now here, you have few variables and we are going to consider 3 variables out of this as the independent variables. You saw that already. Here you can see that. Functional value, emotional value, and opinion leadership. So we say that these are impacting purchase intention. My question to you is, so purchase intention is only one variable, but you have 4 statements for them, 4 Likert type statements. Why is that? Did I teach you already? Why would you have 4 statements? Why would you have 4 statements. Now you have only one variable, purchase intention. So if you look at these 4 statements, now I'm taking this as an example. It applies to all variables I have listed in part B, section B of this questioning. So my question to you is, why do you need to have 4 statements for one variable? You could have asked one question. My statements are clear. Anyone could answer it? Now see here, still it's creating the PowerPoint. See how nicely it has done. So still it's creating the data, getting the data, and network abstraction. It's doing that. Right. Later about that. Right. Okay. Purchase intention. Why do you need to ask 4 question statements? Now, gender, you did not ask for the gender in 4 different ways. Now, your purchase intention, you're asking 4 different ways. And if the reliability validity was there, we created one variable, right? I think you can remember we use theegen function,egen raw mean. Now, today we are not going to use them. We are going to use SmartPL. It's a more advanced way to do that. Okay, students, why do we need to ask the same thing in 4 different ways? Anyone? Anyone? එකම දේ 4 විදිහකට අහන්න ඕන. Why is that? Because these are all perception-based questions. Perception-based questions. So if in case, if one question was misunderstood, you can take the average of the other 3 questions. Let's say this was misunderstood. Then you can take the other 3 questions and take the average and create the purchase intention question, the variable. Same thing applies to the other recurrent type questions, right? So that's why you ask the same thing in 4 or 5 different ways. At least I would say 3 ways, right? Is that clear? Right. Now you understood the structure. Okay, structure of the questionnaire as well as the variables. Now let's go back to this conceptual diagram. This is called a conceptual diagram because it has the independent and the dependent variables. So you can see here there is 3 independent variables: functional value, emotional value, opinion leadership, and then you do have the purchase intention. That's the dependent variable. Okay, is that clear? Now let's see how to test this model. Now, if it is, stata, it's a simple thing. First of all, you have to check the what? Reliability, then the validity of these statements under each variable. And if those are valid and reliable, you will create the variables and then you will run the regression, correlation, descriptive analysis, and other all analysis. And that's what you should have done under your individual assignment, as well as group assignment, particular group assignment. Of course, individual assignment only up to descriptive statistics. Group assignment, you have to apply all what I have told you, right? Including today's smart PLS for the group 1, right? So apply these rules. Okay, so let's how to now using smart PLS, let's see how to draw the model and then run the model and test the model. So there are several things that you have to understand that I'm going to teach you. Several things I'm going to teach you. So listen very carefully and if possible, apply it. If not, watch the video and then apply it. Because I expect you to apply this for your group assignment as well, right? Okay. So let's see how to now draw the model and run the analysis. So it's very simple. So once you now open Smart PLS, I told you have to define the workspace somewhere here. The workspace would be there. Once you define the workspace is the just a folder where all your information will be stored, right? All the information will be stored. So now to run this one, what you'll do is you'll go to new tool. First of all, we have to go for a new project. all the existing projects. You can see I have several projects. I'm using this to teach as well as to do my own research. So you can see several projects are there, which I run up to now. So then you can go to new project and give project name. I'm going to say, okay, SAB music, do any name, premium, yes, I'll say 2025 August or September. It's too long. Okay. SEP. Don't put a dot. Then to give a red. You just say SAP Music Premium case 2025 SEP September. Give any name. Give your own name if you want, but give a meaningful one. Right? Then click create. So then what it will do is it will create, right? Like this. You can see here. SAP Music Premium. So it's a case. A folder is created. So that's called a project. Right? Is that clear, Buddha? Students, is it clear? Then what you have to do is then you can now import the data. So next step would be you created a folder, a project that we call, and then what you can do is you can import the data. You can go to import data and go to the location where you downloaded Excel file. So here is my Excel file. So I'm going to go to this location. You can download this Excel file from the LMS. Right. So let me show you that Excel file. Okay, now it's the artwork is being created. So the Excel file is over here. Yeah, RA Premium database. So that's the Excel file. So please download it, and then that's the file I'm going to import. So you can see it's creating a very elegant. There are other like platforms to do that, but again, right. So here this is the RA Premium database. It has all the data. You can say open. Then the import wizard starts. So it says unexpected error. An unexpected error occurred using the error. Right. What we can do is in this case, if this error occurs, let's try another. Because Excel files sometimes might create problems. So what you could do is, okay. By the way, you can see ChatGPT has created that. I'll show you later. Allow to see that. So if it doesn't work, why not you use the SPSS file? The same thing in SPSS. You say RA Premium database, please download that. Right. Same file in SPSS. That's the data file. So we'll try to open that. Import file. SAV. Open. It's getting opened. So your data, what try to do is it's trying to now get the information from the data file. It's an SPSS. It's .sav. It's an SPSS file, a data file. So it has identified that these are the variables. And then it gives some basic descriptive statistics. So it's going to import. Then it says in certain instances, there are missing values. Already I told you now, for an example, age has 2 missing values. Now, Smart PLS does not tolerate missing values. Stata, SPSS, those software doesn't mind missing values, but smart PLS, it cannot tolerate, right, missing values. Missing values are values that now age you cannot keep blank. Here two people have kept it blank. Then marital status, three people have not told whether they are married or not. Now it's not a big question, isn't it? But either you are married or you are unmarried, or some other status are there, but you cannot say, you cannot keep it blank. Three people have kept it blank. Maybe they have forgotten whether they are married or not, or they couldn't count, how many wives or husbands that they have. I don't know. Maybe. So in that case, we have to now define the missing values. So what we can do is we can give a huge value, right? In your case, the interface might be a little bit different, right? But here you can see it's maybe on the top where you can click and say define missing values. So here I'm going to give you a huge value, right? 999. And then I'm going to say apply marker. So in your case, it might be on the top. So missing values, and you can say 999 and apply marker. And you can see here, these are all missing. Now missing values applied, so it became now green color, right? For the missing values, I have now applied 999 because age and marital status cannot have 999. A person cannot live 999 years. And marital status, there are only few. Marital status is 1, 2, 3, 4, something like that, but it cannot have 999 as a marital status. So that's done, and you can see now it's green color, and you can now press import. In your case, import might be over here. So press import. So you can see the data is now imported. Okay. The data now is imported to Smart PLS. So there are 31 sub-variables and there are 375. There are 375 observations. And then there are 5 missing values which were treated. Right, that's it. And you can go to back. And now you can see here in disks, a set of disks are there to indicate that you have got your file, data file. Right, you have got your data file. So that's how you could import data from Excel or from, let's say, for an example, SPSS to Stata. Is that clear, Uda? Is it clear? So let's go and see our experiment. Still it's creating because it's 30 slides. Okay, never mind about that. Okay, so is this clear? Right, hope it's clear. Right, if not, do this again. Right, then what you can do is, then afterwards we can go and create the model. Now you created the dataset, you imported in fact the dataset, and now you can create the model. You go to create model, and then it asks here, okay, give model name. And first of all, model type. I will select from here PLSM, partial discuss structure equation model. And then I'm going to give a model name. I'll say, okay, SAP Music Premium model. Anything, right? You can just give any name what you want. And you can say save. Okay, now you can see there's a canvas over here and all the variables related to this studies there. Okay, so this is called the canvas. This is called a canvas, that where you're going to draw your model visual. Okay, so now let's try to mimic this one. Okay, the conceptual model. So first you can see the functional value is there. So I'm going to pull functional value related indicators. You can see the functional value is here. Functional value. FE1, FE2, 3, 4. So these are the functional value related sub questions. So I selected all four. First select the all four. These are the sub questions of some function value. Four statements for their function value. And what I'm going to do is I'm going to select these first, right? I'm going to select one and then shift and down arrow key. So I select all and then I will drag this and drop it into the canvas. So it asks a name. It gives FB functional value. I'll keep it as it is and I'll hit enter. So you can see there's function value, but variable has come. So these are called indicators, the four statements. And these are the functional value variable, right? I would like to have these four indicators not from this side. I would like to have them this side. You will understand later why I did that. Because I'm going to draw the dependent variable here and I'm going to draw arrows. So in that case, these will be some disturbances. So what I'm going to do is I'm going to put these indicators to this side. How can I do that? I can use this pen over here. You can see there's a pen over here and I can shift them to this side. So by pressing this one, I shifted the indicators, the four statements for function value this side. So I took that. Then emotional value is there. Emotional value. EV. EV1, 2, 3, 4. 3. Actually, emotional value, there are three statements. Emotional value. So I selected them. Select the first one, then shift down arrow key. I'll press shift and down arrow key to select the three. And I drag and drop it over here. Emotional value. Again, I would like to align with this. And I'm going to have these three statements for emotional value over this side. So yes, then I can keep this space over here. And I'm going to be a little bit down. And then I'll select the next one. Opinion leadership. So opinion leadership has four statements as you show. So OL1 to OL4. And I'm going to drag and I'm going to drop it over here. So it says OL. So leave it as it is, the name. Hit enter. So it will come over there. And again, I'm going to use this pen over here to arrange the indicators at this side. Now it will look like this. So you have your three independent variables. And now let's put our dependent variable. What's our dependent variable? The dependent variable, you can see here, it's purchase intention. PI1 to PI4. So I'm going to select PI1 to PI4, purchase intention 1, 2, 3, 4. These are the four statements. And I'm going to drag and drop over here. So PI is the variable name. So yes, you can see now your three independent variables are there and your dependent variables are there. Right? Is that clear? If you have any questions, ask me. Then what I'll do is I will now connect these independent and independent variables. So I'll use now it's a select is being selected here. So I'm going to use connect. Here the connect is there. I'm going to use connect this to here. So once connected, you can see it becomes blue color. So if something is red, that means something is wrong. It has become blue color. Red color is not okay. Orange or red, I think something, right? So that's not correct. So I'm going to now connect this also. I'm going to keep my cursor over there, then tap on this, and then while keeping my cursor on it, right, I will connect it to the purchase intention. Same thing here. I will click on this, and while being clicked, I'll open. So now you can see your three independent variables are there, and your dependent variable is there. So this is how you will visually draw this diagram. Now you have drawn your conceptual diagram, and you are going to save it. You can see here the green color button, or some, in your case, it might be some other color, right? I'm going to save it. Right? Is it clear?
Excuse me, sir.
Yes, Buddha.
Yeah. Can you show how you connected them?
Okay, Buddha. Let me show you. So I'll remove the connectors. Right, I'll remove the connectors. So Buddha, it's like this. And Buddha, මෙහෙමයි කරන්නේ. මෙතන ඉස්සෙල්ලාම ගිහලා පුතා connect කියන එක select කරගන්න. Right? ඒක select කරලා ඊට පස්සේ what you have to do is මෙතන ගිහලා click කරන්න. click කරගෙන ඉඳගෙනම while you click it, don't raise the mouse and then drag and drop. Right? Point it to PI and then release the mouse button. mouse එක තද කරගෙනම තමයි පුතා අතනට ගිහිල්ලා මේව කරගන්නවා point කරනවා. ඊට පස්සේ මේකත් එහෙම. මෙතන ගිහලා click කරන mouse එක click කරගෙන පුතා මේ පැත්තට යොමු කරන්න. මෙතනත් එහෙමයි mouse එක click කරගෙන මේ පැත්තට යොමු කරන්න. හරිද?
Yes, sir. Thank you.
By all means, I'm very happy. At least one student. I think it was Adolphus, no? කටහඬින් නම් තේරෙන්නේ එහෙම තමයි.
Yes, sir.
Okay. Then I'm going to save it. Good. Right. Done. It's perfect. Right. I'm extremely happy. එක student කෙනෙක් තමයි ප්‍රශ්න ඇහුවේ. I'm very happy about that. ඒ කියන්නේ කෙනෙක් හරිම පුතා මේක මාත් එක්ක කරනවා කියන එක තමයි අදහස. So very happy about that. And I hope others are also doing that. නැත්තම් පස්සේ හරි කරන්න. කොහොමද group එකේ assignment එකට මේක දාන්න. අදම මේක ඉතින් apply කරන්න තියෙන්නේ. You can apply that. Apply this, push this and apply it. Right? Okay. So that's the first part what you have to do. So here now you have drawn the conceptual diagram. Right? Not like in Stata, in Smart PLS Buddha, you can draw this and you can run the diagram visually. Then after this is what I have told you. Mom, a short note I did. Then I give a short note. What exactly I did. Right. The next one, what you have to do is you have to understand, right? Now here there are two kinds of models, right? There are two kinds of models. What are these? Now this inside part where it connects between the variables, functional value, purchase intention, emotional value, purchase intention, then opinion leadership and personal intention. This inside part, which I have drawn here, the black circle over here, it's called the what? Structural model or inner model. Structural model, inner model can accurate. So the black circle shows that. But on the other hand, the outer part, you can see here the outer part is there where the indicators are there. This yellow color things and arrows. And then this is also that right part of them. The red color circles indicate what? The outer model, which is also called the measurement model. Again, let me repeat. The inside part is known as what? The structural model or the inner model. By the inside one. The outside part is known as the what? Outer model or the measurement model. Students, only my internet connection got cut off. I hope you can hear me. Students, can you hear me, Buddha?
Yes, sir.
Okay, Buddha. Thank you. Suddenly, my internet connection, Buddha, got cut off. So I came back. Right. So the inside is known as what? These, now you can see the blue color variables being connected. That model is called what? The inner model. And also it's known as the structural model. Then put on the outside, the yellow colors and these blue color ones are being connected. That's called the, which I have indicated in red color, is known as what? The outer model or the measurement model. And what I was telling is, in Smart PLS, first we have to run the outer model or the measurement model and see whether it's okay. And if it is okay, Puta, then we can go to the inner model or the structural model and test them. So I'm going to teach you several things of that. Right. So then let's come back. Let's go here. Measurement model or the outer model assessment. Measurement model or the outer model assessment. That's what I was telling. First, start with the measurement model. And to test that, right, you are going to check that using different kinds of criteria. Like you are going to look at factor loadings, right? We call it indicator reliability. We are going to check that. Then we are going to check the reliability, validity, right? Likewise, several things we are going to do. There are three kinds of validity we are going to check. Actually, mainly two kinds. The discriminant validity and convergent validity. I will teach you what are those things. Then to check the discriminant validity, you have three further criteria, right? The Forner-Lanka criterion, HTMT ratio, then cross loadings. Likewise, you can check them and validate your outer model, reliability and validity. Then you can also use fit indices, how fit your model is, right? You can remember we discussed R squared, the explanatory power of the independent variables. The explanatory power of the independent variables. Likewise, we can see now here we have three independent variables, whether those three independent variables explain well the dependent variable for its integer. Likewise, we are going to look at all these things, right, in validating the measurement model. So let's go back and see how we can test this outer model. How to test the outer model. So that's what we are going to look at. It's extremely important. I hope you will do it and understand it. So to test that, what we'll do is we'll go to Smart PLS. Look at very carefully. We are now going to check the what model? Outer model, which is also known as measurement model. So once you are in this screen, what you can do is you can go to calculate. You go to calculate and PLSM algorithm. You go to PLSM algorithm. And then this dialog box comes. Since you are going to check the factors, right? Factor, you are actually what you do is here, you do a factor analysis and see the factor loadings of these questions, statements, also known as indicators. You will see that closely, right? Soon you will see that. So just make sure that you have chosen factor. If it is not done, that's all what you have to choose. And you can say start calculation. Once you run that, you will see here factor loadings are given. So let me use the magnifier so to show you that. Magnifier. So you can see here. I think now you can see a much better picture. Now here you can see functional value. So these are the factor loadings of these FP1, FP2, FP3, and FP4. There were 4 statements. So you can see the factor loadings are above 0.5. So it's very good. If it is above 0.5, it's good. Even we can go up to 0.4, right? But if it is above 0.5, that's said to be quite good. So here you can see all statements have factor loadings that are above 0.5. What are factor loadings? Already I told you. Factor loadings are the correlation. Factor loading is a correlation between the relevant statement and the variable. Here the variable is functional value. The statement is FE1. So it has 0.782 correlation. That's what it shows. Higher the better. Then how about here? Emotional value. Here you can see there are three statements. All three statements are above 0.5. There is no issue. Then opinion leadership, you can see again here, these are all above 0.5. Oil 1, oil 2, oil 3, and oil 4. So I don't see an issue. Then if you go to the dependent variable, here this PI also has 4 indicators. They also, the factor loadings are above 0.5. So that's a very good thing to see. Right? In case, if an indicator had less than 0.4, then you might need to delete that. So select it and you have to delete it. If it's less than 0.4, usually you will tolerate up to 0.4. And if it is less than, now here nothing is less than 0.4, but on the other hand, if an indicator is less than 0.4, you might need to delete that. Here you don't need to delete anything because all are above 0.5. So that's the first thing that you'll be looking at. Right, so I have indicated that here. Please look at that carefully, right? Here you can see. So I have given a note over here. So just calculate PLS algorithm, choose factor, and then start calculation. Just see whether it's above 0.5. Right? But if it is below 0.4 only, you might need to consider deleting it. Right? Then afterwards, you have to check the reliability analysis. Right? Already I told you that you can check reliability. How? Under factor analysis tutorial lesson, I taught you that. How you are going to check the reliability of a set of Likert type questions related to a variable. How you are going to check that? Using Cronbach's alpha. Using Cronbach's alpha. And here there is an additional reliability criteria called composite reliability. There are two things like row A and row C. Yes, row C. All should be above 0.7. You know that I told you. Cronbach's alpha value, if it is above 0.7, that's said to be good. So what you could do is you could go back to SmartPLS, and to see that you have to go to this pane. You can see that there's a pane over here, and you can go a little bit down, right? And you can see under quality criteria, if you go down, you can see here, construct reliability and validity. Right, again, if I go to, I'll enlarge it, right? If you go here, you have graphical, and then you go down, final results. Then under quality criteria, you will see construct reliability and validity. Please select that. Okay. So you can see for all your variables, it indicates the Cronbach's alpha. So you can see the Cronbach's alpha is above 0.7 for EV, FE, oil, and PL. Is it good? Good or bad? Extremely good. Extremely good. It's above 0.7. Extremely good. Right? Cronbach's alpha is good. No problem. So reliability is there. And also you can see another kind of reliability is composite reliability, row A and row C. That also you can see they are also above 0.7. So there's no any issue. So you would conclude, right, the particular variables that you have considered is having reliability, high reliability. Okay. Clear. Reliability is there. Then what you need to do is you need to check the convergent validity. Converge means what? Whether these indicators come together, right? Convergent validity. Whether these indicators come together and form a construct, coming together. Convergent means coming together. So now for an example, if you look at again this diagram, I'm going to go to the diagram. If you go to the diagram, go to the graphical output and graphical output, you can go here. So all these factors, the indicators, these are called indicators should come to 1. That's called functional value. These indicators should come to 1. That's emotional value. That's called convergent value. Reliability is about consistency. Now we are looking at convergent value. It converges to 1. To check the convergent validity, right? To check the convergent validity, we use a criteria called AVE. What's AVE? I have got it here. Right? AVE is what? Average variance extracted. AVE, average variance extracted. To check that, we can check the AVE. So the AVE is said to be, if the AVE value is above 0.5, it's said to be having convergent validity. So to check that, you can go back again to over here, this area, and I'm going to enlarge it to this area, and you're going to go down, 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 again quality criteria, go to the same thing, construct reliability value. And you can see here, let me make it smaller. You can go to the corner and you can see these are all above 0.5. These are all above 0.5. Okay? If something was below 0.5, then it would have been a problem. But here, there's no issue, all above 0.5. So we conclude there's what? Convergent validity. We conclude there's convergent validity. So likewise, you have now checked the reliability and the validity. Two things you have checked. Under validity, you have checked what? The convergent validity. And next, what we are going to do is after the break, we'll check the divergent validity. Whether these are different, or these variables should be different from each other, isn't it? Now, there are 5 variables, including the dependent variable, actually 4 variables. So these 4 variables should be different from each other. That's called divergent validity. To check that, there are 3 ways that we can use, right? Discriminant validity, divergent validity. We can use the HTMT ratio, Lanka criteria, as well as cross-variance, right? After the break, we'll do that. We'll try to check, right, the discriminant validity or the divergent validity. Okay, so shall we take a small break now? So now it's almost 9:05. Shall we meet at 9:25? Okay, 9:25, and let's go up to 10:30. So I'm going to teach you all. It's not difficult because SmartPLS does the difficult thing, does the analysis. What we have to do is just run it. Okay, run the model and understand how to interpret. Okay, so after the break, we'll discuss how to check the discriminant validity. Up to now, what we have checked? We have checked these things: reliability and convergent validity. In validity, I told you that there are 2 kinds of validity: convergent validity and discriminant validity or divergent validity. So we already checked the convergent validity, whether these indicators come together. Okay, After the break, we'll do that. And let's see what happened to our ChatGPT thing, no? As usual, it got a little bit stuck. So the agent mode still, it's working for 15 minutes. So let it work and someday it will come and we'll see how good the presentation is. Because 30 slides, no, it was too much. Okay. That's something extra, right, than smart PLS. Okay. Right. So we'll discuss the next things like that. So we'll discuss the discriminability after the break. Okay, students, meet you at 9:25.
නිකන් ගත්තේ බබා මගේ data load වෙන්නේ නැහැ බබා dialog එකේ මං 3-4න් බැන්නත් එක කෝල් කළා. නෑ නෑ අපි 1500 ගණන් පැකේජ් දාන්න බබා data GB 15කුත් තියෙනවා insta නම් මම ඔක්කොම free කියලානේ දෙන්නේ. රෙද්ද insta කරන එක යන්නවත් බෑ පැය ගණන් load වෙනවා Facebook වීඩියෝ එකක් load වෙනවා පැය ගණන්. hotspot ටිකක් දීලා මේකට යන්න බෑ මේ
ඉසුරු මයික් ඔන්
මේ විනාඩියක් දෙන්න.
ඉසුරුවයි මයික් එක ඔන්න ඉසුරුවයි
Okay, students, welcome back. Can you hear me?
Yes, sir, here.
Okay, Buddha, thank you. Thank you very much. So now we are, right, as I told you, we are checking the what? Outer model or the measurement model. In checking the outer model, again, if I little bit remind you what we did was this the outer model, which is in red circles. First, we check the factor loadings. And I told the factor loading should be above 0.5. You can tolerate up to 0.4, but if it is above 0.5, that's good. Then you check the reliability. To check the reliability, you check the Cronbach's alpha value as well as rho A and rho C, which are composite reliability values. They were also fine in this case. Then I told you when it comes to validity, there are two kinds of validities. Convergent validity, whether these indicators are coming together, and then divergent validity or discriminant validity. In checking the convergent validity, you were looking at the AVE values, average variance extracted values, which should be above 0.5. Should be above 0.5. And here, for this example, we saw it was in fact above 0.5. Then we are going to look at now the validity. Validity. So here what we are doing is we are checking the discriminant validity. Right? Now, earlier it was convergent validity. Discriminant value means whether these four variables are different from each other. Because these are four distinct variables. Right? 3 independent variables and 1 dependent variable. So these should be distinct, different. Now that's what we are going to check. To check that, we can use 3 criteria. One is called the HT-MT ratio. Here we can see that if the HT-MT ratio is less than 0.85, it's said to be good. So how to check that? So what you can do is you can go back to Smart PLS and then you can see here discriminant validity is there. Let me enlarge. You can see under quality criteria, you will see discriminant validity is there. Under discriminant validity, you have HT-MT ratio. Heterotrait monotrait ratio is the HT-MT ratio. You can see the HT-MT ratio is given. In all cases, these are well below 0.85. Well below 0.85. So I see that there is discriminant validity under this criteria, HT-MT. Right? So that's one criteria that we could use. HT-MT values. Heterotrait monotrait ratios. Then you can look at the Forner-Lanka criterion. Simply, what's Forner-Lanka criterion? Let's go back. So if you go here, Forner-Lanka criterion is, you can see here, there is under discriminant validity, there's another one called Forner-Lanka criterion. Simply what it means is, you can see this is the diagonal, right? EV and EV, this is the one, the first one, then this is the second, third, fourth, likewise you can see this is the diagonal. All values across and below should be less than these values. Now let's see that is satisfied, whether that condition is satisfied. Now 0.805. So anything below this should be less than 0.805. It's less. Then 0.808. This should be less. 0.773. It should be less. Yes. These are all less. Then across it has also be low. 0.808, 0.392 is less. And 0.773 is the value in the diagonal. These two values are below this value. Then 0.790, these three values are also less than 0.790. So that's called Forner-Lanka criterion, right? As we saw under HT-MT, here also we can see that these values are less than the diagonal, right? In that case, we can confirm that discriminant validity or divergent validity is again established under Forner-Lanka criterion as well. Then finally, there's a third way that we can establish. This is the second criterion, Forner-Lanka criterion. Then we can look at the cross-loadings, right? The cross-loadings. So what's cross-loadings? Already you have seen that. Let's go to the last now. If you go here, you can see cross-loadings are there. Cross-loadings are there. Cross-loadings. Now, here you can see EV. For EV, you can see EV 1, 2, 3 is there. So you can see all the values are above 0.5. These are the loading factors. But for EV1, EV2, EV3, for FE, those are smaller values. So you can see this EV1, EV2, EV3 has been loaded under EV. But what cross-loading means, basically, if for, let's say for an example, EV2, there's a huge value for FE1, let's say it's 0.7 also, then something is wrong. It has cross-loaded. EV2 has cross-loaded under EV as well as FE. So there is no issue like that. Then if you take FE1 to FE4, again you can see under FE, those values are higher. Under other things, it's low. So you can see it's distinct, discriminant validity. Then oil, you can say for oil, the same thing is observed. Oil 1 to oil 4, it's all above 0.7. For other, right, EV and FE, it's low. So PA1 to PA4 is the same thing. So you can see these are the factor loadings, and there are, you check the cross loadings over here. Cross loadings are not cross loaded. They are distinctly loaded under each construct. So you have established discriminant validity in 3 ways. What are 3 ways? What are 3 ways? 1, HTMP ratio, which should be less than 0.85, which we saw. Corner-Larkin criterion, the diagonal across and low, the things below should be less than the diagonal values. Then cross-loadings also, we saw that there was nicely loaded, not cross-loaded. So that's how we establish discriminant value. So you checked both reliability and both kinds of validity, convergent validity and discriminant validity. Okay, clear? So when you are going to do your analysis, please check this and report this, right? Report this. And then you can see the fit indices, how much fit or how much explained power your model has. You can look at the R squared value, and then you have NFI, SRMR. The thresholds are given here. Now, for an example, SRMR, standardized root mean square residual should be less than 0.08. Then R squared should be just higher the better, that you can remember. Above 0.5 is good, even more is good. So we can go and check these things. You can go to here. And you can see model fit is there. Model fit is there. You can see. In model fit, you can see SRMR. Ah, yes, it's less than 0.08. And NFI is there. NFI then has a small issue there. We'll see. NFI, you are looking at here, NFI should be above 0.9. But if you see here, NFI is 0.75. Not a big deal, but you can see there's a small issue. So likewise, but again, SRMR is okay. And yeah, those are things you could look at. And R squared is here. Oh, R squared is a very small amount, 0.167. That's so model fitness has an issue, right? Based on R squared, it's 0.167. That means what? These three independent variables could explain only 16.7 of the purchase intention. The model fit is not so good. Only the SRMR is a little bit compliant, but that also here it's a bit okay. But again, when you look at the R squared value as well as the NFI value, those are quite low. So model fit is not so good, although the outer model is validated. The measurement model is validated. Okay, so you satisfied yourself. Overall, there are no issues, although the fit indices are not showing quite very good fit, right? Okay. After doing that, Puta, what you can do is, right? You can check for the inner model. Now that's the outer model we checked. Then we can check the inner model. Inner model is the structural model. Actually, that's where you check the relationships, the impact of the independent variables over the dependent variable. So if I again show you that the inner model, you can see the inner model discusses the relationships. Right now here, oil, Fe and Ev, how it impacts Pi. That's the most important part. In fact, you check the measurement model, you check whether the measures are okay, and now you check the relationships. Because if you don't check the measures and if you directly check the internal things, then there's a problem. Because it might not be the accurate depiction. Measurement first you have to check whether the variables are measured properly. Once you check that, the outer model, the measurement model, then you can come to the inner model, which is the structural model. Okay, let's see how to now check that model. So the inner model. To do that, now these are okay. You can go to your model and you can go to here, edit. Right, you go back to the original canvas and you go back to calculate. And now you are going to go to something called bootstrapping. Not PLSM algorithm, which you now, when you wanted to check the outer model for the measurement model, you went to the PLSL algorithm. But when you want to check the inner model, right, or the structural model, go to bootstrapping. Go to bootstrapping. Okay, keep that in mind. And bootstrapping means you are going to run this 5,000 iterations. Here it says 5,000. 5,000 times you are going to iterate this. So then PLS, then go to PLS setup and please select path. Because now you are going to check the path coefficients. You are going to see the path, the relationships. Earlier we checked the factor loadings and other things. Now these are paths. So please select path. That's the only change that you have to do. Keep all others as it is. The defaults you can keep as it is. Right? And let's run start calculation. It's a huge calculation that will take some time. See, let's calculate it. Okay, the calculation done. Excellent. And you can see, now we can see whether the relationships are okay or not. So to do that, again, you will go here and you can see there's something called path coefficients. Go to path coefficients. Then you can see very nicely here, see. These show how the independent variables, EV, Fe, and oil, these are called the paths. EV, Fe, and oil impact the Pi. So if you look carefully, you can see, right, you can see EV on Pi. Is it significant? The P value is above 0.05. So EV, we conclude, has no significant impact on purchase intention. But how about Fe, functional value on purchase intention? There's a significant impact. How about oil, opinion leadership on PI? It is significant. So two paths are significant, two variables are significant. That's your conclusion. Two variables are significant. And you can go and see it on that diagram as well. You can go to the graphical output. And here you can see over here, it shows now here, these lines, it shows the significant levels are indicated. 0, 0.064, then 0. And here you can see the R squared is indicated within brackets. And now if you want to show in the paths, both the P value, the significant value, the inner model, the P value as well as the path coefficients, then you can put the path value. So you can see the path coefficients 0.227. What it means is when functional value goes up by 1 Likert scale, purchase intention goes by 0.227 Likert scale. So that's what it indicates here. So here it's not significant, so you don't need to interpret it. But here you can see this one, oil has 0.209 impact, all positive. So both of these are positive. This one we don't interpret because the significant level is above 0.05. So in that case, you can recommend to increase purchase intention, increase the functional value, and increase the opinion leadership. Use more opinion leaders to promote the item, promote this music premium app, as well as increase the functions of the music premium app. So that will increase the purchase intention. So that's the conclusion. Right? Finally, that's what you conclude. See how easily you can perform a visual analytic with several diagnostics. So that's why we say this is the next generation of regression analysis. Now, even if you do this using Stata, you will get the same answer, right? Because we ran, now to teach you, I taught you this basic model. But even if you run this in Stata, you will get the same answer. But if the model gets complex, then Stata cannot handle that. Now I'm going to make it purposely complex, right? Is this clear up to this point? Complex karmuko passe. Now do this for your group assignment also. Huh? Apply this. Now you have all the questionnaire, you have the data set. It's only to draw this, conceptual diagram like this, which I taught you, and check those diagnostics, report those diagnostics. As I told you, start with what? Reliability. Put that reliability table, and then put the convergent validity, the AVE value, then discriminant validity, report those three, Lanka criterion, HTMT ratio and cross loadings. And you can establish those things. And then once those are okay, you can come to, even if it is not okay for your example, no problem, because you are using a bogus data set for your, then based on that, you can run the inner model. And you can say if it's significant or not significant. And then you can comment on the recommendations. I told you, right, under regression analysis, only give recommendations for what? Significant variables. Now I'm going to make purposely I'm going to make this complex. Now you can see, I'm going to save this. If you want, you can save it, right? And then you can go back and you go to the original model and go back. And you are going to go to the canvas. You can see the canvas is over here. This where we drew the original model. Now I'm going to bring age as a moderator. So age, I'm going to bring a moderator. I'm going to take age variable. There's only one right question for age. You don't ask three questions. So age, hit enter. So age is there. Now I'm not going to draw, a straight arrow for PI. I'm going to say age is going to moderate between functional value and purchase intention. Age is going to moderate between emotional value and purchase intention. Age is, let's say, going to moderate between opinion leadership and purchase intention. Moderation means that. Moderation means it's going to strengthen or weaken relationship. So I took age, and now let's see. Yeah, I'm going to use this connect button over here. And what I'm going to do is I'm going to keep my arrow over here and draw the arrow onto this arrow. This means it's a moderate, right? I have drawn to this arrow. So what it says is age could strengthen or weaken the relationship between functional value and purchase intention. And I can also draw another arrow from there to this one, this arrow. Here what it says is age could strengthen or weaken the relationship between emotional value and purchase intention. And again, I'm going to draw another one over here from here to here. Here what I would say is age could strengthen or weaken the relationship between opinion leadership and purchase intention. So these column moderate. Now for your final exam, expect such kind of a moderate, right? Because now it's complex, little bit complex. It's not a complex one, but these kind of complexities, it's difficult to handle in Stata, right? It's difficult to handle in Stata. But if you do that in Smart PLS, you can see how easy you can just draw it and you can run the model, right? So now what you can do is, first, again, I would ask you to validate the what? Start with what? The outer model or the measurement model. So how to run the measure? So quickly I'm going to do that. You can go to calculate, PLSM algorithm. Make sure it's factor. You're going to get the factor loadings. That's why factor. And say calculate. And then you get the factor loadings. You can see just all the factor loadings are above 0.5, above 0.5, above 0.5. Then if you go here, purchase intention, it's all above 5. Here it's 1 because there's only one indicator, age. So there's no problem. And then I'm going to go and see under quality criteria, construct reliability and validity. Just all converse alpha is above 0.7. Composite reliability also above 0.7. And row C, row A and row C both are above 0.7. And then convergent validity, I'm going to go to the code. This in this table itself, it's there, AVE values. So let's go and see that. Here the AVE values in the same table is above 0.5. Average variance extracted shows what? The convergent validity. So all above 0.5, no problem. Then you will go back and you are going to check the discriminant validity. Under discriminant validity, you can see you can start with heterotrait monotrait ratio, HTMT ratio. So I'm going to go over there. And here I don't see any issue. Now you can see this is the interaction. Okay, these are three interactions. Age is interacting with functional value. Age is interacting with emotional value. So these are the independent variables then which we'll be looking at. So these are called the interactive terms, the moderation terms, the moderating variables. There are three because we have three moderations. So in all cases, you can see it's less than 0.85. So that's also fine. Discriminant validity, HTMT is the standard. Then Fauner-Larkin criterion. Again, I can see all are below the diagonal. So nothing is above that. And I can go to cross loadings. Under cross loadings also, if you look carefully, there's no cross loaded ones. Age, you can just omit that. Then emotional value, you can see EV, yes, the loadings are high. FE, the loadings are high. Likewise, we can see them. PI, that's also we can see. So there are no issues. And you can see the model fit indices. Again, here there's an issue. SRMR is fine, but again, NFI is not fine. And R squared value, here we saw the R squared value somewhere here. The R squared value is 0.18, is slightly it has increased. Slightly it has increased. It was 0.167 earlier, now it's 0.83, so 18.3%. So you validated the outer model or the measurement model. So you are okay. So therefore now you are going to go and see, right? You are going to go and you are going to check what? The inner model. To do the inner model, what you do is you go back and you go to calculate and you go to bootstrapping. And here the only change what you have to do, you have to go to PLS setup and choose path because you can path provisions. And you're going to say start calculation. Huge calculation would take few seconds. Perfect. So here it's done. And so you can go to now the path provisions. And you can see here, age on PI, you are not going to look at because age is a moderator, but this is not the moderating relationship. It just says age on PI. But here these are the moderations. Age on functional value on PI. So age is, we are looking at how it's impacting the relationship between FE and PI. So we can see the relationships over here, right? smaller. Right, and you can see here. So here these are the coefficients, and you can see here FE has the direct relationships we saw were significant. Still, those are significant. FE on PI is significant. Then OL on PI is significant. So functional value and opinion leadership has significant impact, a positive impact, you can see, on the dependent variable purchase intention. EV has no impact. Then moderations. Now there are three moderations. Right? We saw there are three moderations. Age on FE and PI, age on EV and PI. So these are called the interaction. These are the interaction term means you are having multiplication, right? Age with FE, age with EV, then on PI, age with OL, then on PI. Here you can see none of these moderations are significant. So we can conclude that age is not a moderator. Age is not a significant moderator. Age has no moderating impact on the functional value, emotional value, and opinion leadership. Maybe you thought that elderly people might be influenced or not influenced by opinion leadership. But he doesn't give any evidence on that. Just there's no impact. Okay. So these things you have to understand. Right. So this is how. So again, finally, what you get conclude is that functional value and opinion leadership are the only significant predictors. Right? Because the p-values of all other relationships are, these are the interaction terms, the moderating impact, the moderating impact is not there. And the direct impact of EV on PI is also not there. Age and PI we don't interpret at all because we are not interested, it's just a variable. We are looking at the interaction terms. Interaction term is the moderation relationship. These are the three moderators. If you look at the graphical analysis, so here, these are the moderators. So functional value on PI, then how age is impact. So that's it. Okay, that's how we would check the moderation impact. Now I can make this even more complex. I can take gender as a moderator and see, right, where age is also there, gender is also there. Shall we look at whether gender is moderating these relationships? Right. So while age is there, I can take gender and go back, say yes, and I'm going to go to the canvas, make it very complex in that case. Now age is there, and now I'm going to take gender. The gender I'm going to take over here. And now I'm going to draw connectors into, again, these three relationships. Right. Again, I'm going to look at whether gender would be a moderator. So since I validated already the outer model, I'm going to directly run the PLS algorithm. So the bootstrapping PLS algorithm was already run. So twice, so I'm okay with that. So PLSM, I'm going to see path, and I'm going to start the calculation. Now, since it's quite complex, two moderators are there. Let's see whether gender would moderate opinion leadership, functional value, and emotional value, and the purchase intention. Okay. So yes, now it's a very complex model, and I'm going to go to path coefficients. And here you can see gender is there. I'm going to see gender when it comes to opinion leadership and emotional value, it's not significant. It's not significant. But when it comes to gender on functional value and purchase intention, it matters. Right? So when it comes to this path, functional value and PI, we go to the graphical output. Right? Right. Functional value and purchase intention, gender plays a significant impact. Gender moderates that, positively moderates that. Right? Gender positively moderates functional value and purchase intention. So one was coded as male, so male seems more preferring functional value. Right? It impacts the functional value and purchase intention relationship. So if I go back to the path coefficient, that's what's indicated. Path coefficients. Yeah, you can see. Gender on opinion leadership, no impact. Emotional value, no impact. But functional value and purchase intention, gender has an impact. So that's what it says. But you don't see the gender on purchase intention because this is not what you are looking at. You're looking at the interaction term. Interaction term is where you're looking at the moderation. So here it's there. Okay. Right. So that's, I showed you how to take these moderations. Mediation is also there. No, I'm not going to teach you that. Don't worry. For the exam also, I'm not going to take that. But moderation, expect. So in the last lecture, I'll introduce you to the past paper and I will teach you how these are tested. And there will be a question on structural equation model. Right? So if you look at past papers, you will see that how it's being tested. Okay. So for your group assignment, include a smart PLS analysis, including a moderation impact. My recommendation. Right. Okay. Any questions? Questions, concerns? Do you have questions, concerns? So maybe I could show you a past paper, isn't it? Oh, I'll do that. Maybe because what usually students, in the last session, I'll show you that on probably Sunday. So Saturday and Sunday, be ready for the presentations. Right? Because we have 15 groups. So I don't know on Saturday itself, we can complete all. Right? So maybe 2-3 groups I'll have to shift to Sunday. We'll see. I'm not sure what would happen, but again, be ready. All be ready to do on Saturday. In case if we, because we have only 4 hours. And remember, I'm going to start at 8 a.m. Right? I'm going to start at 8 a.m. And I expect the first group to be there at 8 a.m. Right? What's the first group? I'll show you what's the first group. And if they are not there, I'm going to reduce marks. Or sometimes I might not take their presentation. At least come on that day at 8 a.m. Right? Then the second group. So let me show you the group. So I'm very thankful for the batch leaders for sharing me the group information. So I'll show you what's the first group. So you can see first group. Now I'll show you what's the first group. Okay. Here, this is the first group. So it will take only 15 minutes. So the other group has to be ready at 8:50. And I'm going to start at 8. If you are not there, I'll give the chance to the next group. And likewise. So all groups will have to come at 8, right? Basically, that's what the understanding is. Therefore, don't think that 15 minutes. No, there's no such kind of things, right? All groups will have to be ready by 8 a.m. And I'm going to take one by one. Right? First group be ready at 8 a.m. And then next group I'll take at 8:15. So all will have to be on time. If you're late, I'm not going to take that and you will get 0 marks. So you know, for presentation, it's 20 marks if you are given. Report 10 marks. So therefore, if you are absent on time, I cannot give you time because we have very limited time on Saturday. So at least on this day come, and if you are unable to come, you are coming from maybe some Jaffna, Kurunegala, Matara or somewhere, I don't know. Right? In that case, if you think it's far, right? I'm also from Matara, so I don't think it's far, but again, some people consider it as fun. Then come at least in the previous day, night, and stay somewhere with your friend or with your relative and come on time. Don't come up with excuses. And the batch leaders, please communicate that to all. So 8 a.m. I am going to start with these people. And sir, එක්කෙනෙක් නෑ, තාම නෑ. ඉතින් එහෙමනම් පුතා මේක මම ගන්නෑ. බෑනේ කරන්න පුතා. We have limited time. So I'm going to finish it on Saturday. So therefore, be ready. Be ready. වෙලාව නැති වුණොත් Sunday දාන්න වේදද මන් දන්නේ. But again, we shall not go for Sunday. Saturday we'll try to finish it. So therefore, by 8:30, I will say all groups be ready. Right? I'm going to take the first two groups first, 8, let's say 8 to 8:15 and 8:15 to 8:30. The first two groups, this is the first group and second group. Then the other groups, I might take randomly. So therefore, all groups be ready by 8:30 a.m. I'm going to not waste my time, and if these groups are not there, if the first 3-4 groups are not there, then I'm going to ask the other groups to do that. If they are also not there, then I have to reduce marks to all. In a group, therefore, be ready with your presentations and with your group members, because we don't have time. I think one student's microphone is unmuted. කෙනෙක්ගේ පුතා unmute වෙලා තියෙන බලන්න කවුද කියලා. Right, so yeah. Right, any questions that you have related to the today's lesson or the presentations? And you need to present the report. I don't need a PowerPoint. මං කියලා නෑ PowerPoint එකක් දෙන්න කියලා. I need only the report to be presented. So you are given maximum 10 minutes, right? Maximum, let's say 10 to 12 minutes, not 15 minutes, because we don't have time. We have here 15 groups. Groups follow up. Therefore, I have to manage time very carefully. And by 12, I have to finish it. Right? Therefore, time management is very important. So be on time. Group number 1, group number 2. Group number 1 you got or the Danushka, at least one person. Madhushankar. Peanut Peter. Malshika. Then Ahmed. Jamil. Are you there? At least one person. So I think the batch leaders are there. Please communicate to these guys that they will have to do at 8, right? And then second group at 8:15, and all other groups will have to be ready by 8:30. And I'm going to randomly pick. Not on sequential order, I'm going to randomly pick. Let them make a without in the Galle. It was that's going to waste time. Okay. Any questions? Questions? By the way, shall we look at what happened to our what we call ChatGPT? So that's got stuck, I think. Yeah. So 30 slides. No, I think it's now okay. Right. Any questions you can ask me. Right. Meanwhile, it does its thing. Let me now arrange for attendance. So let's go for attendance now. So today there is no session, so I'm going to add a session. So today is 9th September, isn't it? 9th September, bright day. So we started around 1930 at 7:30. And we are going up to 22:30, just 10:30. Right. And so student allow view. So that's right. Rotate QR code. Add. Okay, students, now be ready to get the attendance. Huh? Within attendance. This is 9th September, 7:30, 10:30. Right. Before we take that, we'll see what happened to the presentation. All right, it says. So here is the presentation. Shall we download it? Right, completely created by ChatGPT, right? I'm just demonstrating. This is the agentic mode. So see, these are the things. So I told 30 slides. And it was complete the standard. How nicely it's done, isn't it? Key definitions, quality management, planning and materiality, risk assessment procedures. Professionally done. With even diagrams. I just uploaded the standard. ISSA 5000. The assurance standard, the new assurance standard. So it has come up with this thing. Right. So that's the agentic mode, right? Okay, just try that. Okay, so attendance. Be ready to get the attendance. Can you see the QR code? Please check whether attendance is there. And you can take the attendance. How is it? Attendance mark and all. Can someone please kindly let me know whether it's working? At least if it is working for you, you can tell me.
Yes, sir.
Okay, Buddha. Thank you very much. Excellent. Really appreciate it. So please mark your attendance. So I expect a nice show this Saturday, right? On the show එකක් expect කරනවා. So do your level best. And each member will have to present, and I'm going to ask questions from each member. So be ready. Other last right? It's 30 marks. Significant amount of marks. Okay, I think all students mark their attendance, no? So we have here 40 students. So let's go and see how many people had marked their attendance. Don't give me surprises and because it's not good for getting surprises these days because not good for my heart health. Mark. There are 40 people. But you can see there are 62%. So 22, right? That shows 22 people are there who are frauds, fraudulent attendance. Maybe some students might be joining from one laptop, I could understand. Right, but cannot be 22. That's what makes the difference. Ethics, right? You might cheat here, but can you cheat forever? And also the other issue is you can cheat here and you are also some people might have helped cheating. That's also wrong. Cheating as well as helping to cheat is also wrong. You are an accomplice in that case. So you start from here and you will end, I don't know where. I don't want to talk about those things, but again, this shows the ethical conduct, honesty, integrity of some people. But again, that's up to you. I'm not going to check. Don't worry at all. Right. But again, there's Puta, I'll just tell with this, I'll finish. But again, there's something called the law of cause and effect. Right? Every effect has a cause. So on the other hand, every cause will have an effect. Every action has a reaction. So Puta, remember, if you do something bad, right, there will be consequences. If you do a fraud, there will be consequences, even forging attendance. And if you are helping someone to forge their attendance or whatever, that's also you are helping to engage in fraud. So remember, Bhutana, right? There is a cause and effect law. And that's for sure. If you do something bad or help someone doing bad to do something bad, there will be consequences. Okay, just keep that in mind. As a teacher, that's I could tell you. And some consequences will ruin your life. It will ruin your life. Okay, with that, we'll finish today. Thank you very much. And good night. Please take care.
Thank you, sir.
Thank you, Puta.
Thank
Good
you,
night.
sir.
Thank you, Puta. Good night. Good night.
Thank you, sir.
Thank
Good
you,
night.
sir.
Thank you,
Good
Puta.
night, sir.
Good night. Good night, Puta. Please take care. Good night.
අපි